first example, we're going to talk about matrix addition. If you notice, we have two matrices that we are going to be adding together. Something else you should notice about the two matrices is that they have the same dimensions. My first matrix has 2 elements in its column and 3 elements in its row, making it a 2 by 3 matrix. And the same goes for my second matrix. 2 elements in its column and 3 elements in its row, making them both 2 by 3 matrices. In order to perform matrix addition and subtraction, the matrices that you are adding or subtracting from one another have to be of the same dimension, otherwise this process isn't going to work. So what we're going to do is we are just going to add each element that is in a similar position in each matrix to create a new matrix. So for example, I'm going to start with the first element in my first matrix, which is 2, and I'm going to add -6 to that, which would give me -4. And then I can move on to the next element. So I have 0 plus 7 is 7. And then I have 1 plus -1, which gives me 0. And that completes the top row of my solution. Now I can move on to the bottom row of my matrices. 0 plus 4 is 4. 5 plus -3 is 2, and -8 plus 10 is 2. And so my final matrix is the same dimensions as my 2 original matrices that I combined together. The next example that we'll look at will be matrix subtraction. We're going to do the same process, subtracting elements that are in like positions. So I'm going to start here with my -7. This time we're subtracting. So -7 minus 6 is going to give me a -13 for the first element in my matrix. Moving on, I've got 4 minus 10 is going to give me a -6. 5 minus 8 is -3. 0 minus -9 gives me a +9. 3 minus -2 is +5. And finally, -1 minus 5 is -6. Again, I started off with 2 matrices of the same dimensions. Each one of these matrices that I had were 3 by 2 matrices. And when I subtracted them from one another, I had another 3 by 2 matrix as my answer. In the next example, we are going to be doing 2 things. We're going to be adding 2 matrices together, but you'll also notice that we have a scalar multiple in front of the first matrix. So what we're going to do with that 2 is we're actually going to distribute it to each element inside of the matrix that it comes in front of. So the 2 is a scalar multiple. It's going to get multiplied to each term of this first matrix. So that changes my first matrix. All of the elements are now going to be multiplied by 2 to give me a new matrix. And then we're not doing anything differently to our second matrix. It only has the plus sign in front of it. There isn't a scalar multiple in front of this one. So that matrix is going to stay the same, so I'm just going to recopy it. And now I'm ready to do my addition. So I will just go through and add my terms together to get my final answer. And one more example I have for you. You should notice on this last example, we have a 2 by 3 matrix that we are trying to add to a 3 by 2 matrix. These two matrices are not of the same dimension. So that means that we will not have the correct number of elements in the first matrix to combine with my second matrix. So this particular problem is impossible to solve because I do not have the same dimensions of my matrix.